I want to talk about stretching CloudStack over multiple data centers, but as you know, you need to start with an introduction. Who am I? And all this stuff. I'm from the Netherlands. My current role is CTO at Euroonline, a group of hosting companies in Europe and also now presence in the US, but we're mainly about online presence. I'm a techie at heart, started my hosting company back in 2003. Apache CloudStack developer. Well, I say I used to be because I don't have time anymore to write code. I would love to, but I don't have the time. PMC member. I love Ceph, and I'm an IPv6 fanatic. So if you want to talk about V6, we can talk for hours, but let's not do it right now. So a bit about Euroonline. As I just mentioned, we have hosting companies throughout Europe. We are acquiring more and more companies. It's our strategy to acquire customers. But we also have infrastructure running. Interesting, we have companies in Spain. Something happened in Spain last week. We stayed online, luckily. Burning diesel for 12 hours and no data center went offline. But since I have 30 minutes, let me talk a bit about CloudStack and about how we deploy it. So your hosting in the Netherlands has a large deployment. Axarnet in Spain has a large CloudStack deployment. Both are still expanding, and more deployments are coming. In 2025, we're going to be deploying a new CloudStack deployment in the UK, and probably in 26 in Germany. And we keep innovating, we keep acquiring companies, and they're all interested in CloudStack. So over time, we'll see more and more CloudStack being deployed. It just takes a bit of time to get it all implemented because there's so many things to do. So, but building a multi-DC environment, I think it's a hot topic which has been debated for years and years. Everybody says, I want to have my cloud deployment over multiple data centers. Well, one thing I always say is that be very cautious if you want to do so, because it's not that you double your price, you'll quadruple your price for your infrastructure. So yeah, we had a major power outage in Spain. And the DCs stayed online just fine. Generators kicked in and they kept running. There was diesel. And we actually noticed that most other data centers stayed online as well because the BGP sessions stayed online. We were online, there were no users because everybody was offline. But hey, at least, well, I think the horror for IT guys in the data center is that you lose power, even for 1 second. Rebooting all the system, getting it all up and working again, that's the horror. So if internet goes down, well, that's a bummer. Power goes down, that's horror. So before you think about doing multi-DC deployments, be very cautious because realistically, how many times do data centers go completely offline, or do you have a physical event which happens at your data center? Is it worth the cost? I would say, so I had this discussion with a large e-commerce website which we host, and he said, yes, I want my website to be multi-data center. Then, well, they talked with him, and eventually I got into the conversation and said, well, it's going to be 4 times as much as you pay right now per month. Oh, that's ridiculous. I said, but how many warehouses do you have where you ship your products from? Yeah, 1. I said, well, I guess the data center is online quicker than if your warehouse burns down. So be realistic. It sounds super cool to do multi-data center setups. It is feasible with CloudStack, but be realistic for yourself before you start thinking about such a deployment. I often would say spend the money on something else instead of building redundancy over data centers. But nevertheless, I'm going to tell you that it's possible. So what do you need? How do you build it? Hint, yes, use VXLAN, EVPN, and BGP. So thank you for listening. That's it. No. Okay, jokes aside. Let's get started. So let's dive a bit deeper. I'm not going to dive into all the exact details of BGP, VXLAN, how to configure it, config examples, because it depends. And this is always the lame answer. It depends on your deployment. So it's going to be a higher level overview of how you could do it and how a small deployment, if you take the right configuration right now, that you can expand it into a multi-DC later on. Because everything begins with the network. I think anything you do in IT starts with the network, but it's always undervalued or underestimated networking. So it's like, no, it's there, it works. Yeah, but nobody really cares about the network. We all talk about super fast storage and new CPUs and network. Yeah, boring. Network guys handle it, and that's fine. But if it goes down, then you always blame the network guys, always. We always blame the network guys. Storage guys always blame the network guys. Yeah, you know, right? It's always up to the network. So start with a proper network design. So if you have a single data center and you want to build something like this, what are you going to use? Spanning tree, rapid spanning tree, something from your vendor, like Cisco Nexus or whatever proprietary stuff exists from your vendor. Is that realistic in a DC? No, you probably don't want to do that. I see heads nodding saying, no, you don't want to do it. But you would be surprised how many spanning tree environments I still encounter. Like a lot. And I mean like crazy amount of spanning tree environment. Because networking is also a bit, it's lame. And so you don't touch it. Because there's no true return on investment on changing the spanning tree to something else, because it works, right? So why would somebody higher up in management approve a project for a couple of months, which is going to cost X? And what's the benefit? Yeah, well, we need to change technology. Yeah, but it works, right? It works. So why change? Yeah, until it stops. Until it stops. So did you CrowdStrike happened a year ago, and you had these memes where you had CFOs. You had a meme. I said there was a CFO signing all these contracts for IT security after the bug hit, right? Because nobody wants it to happen again. But you would never have the CFO signing those contracts before CrowdStrike hit. It's these kinds of, it needs to happen. So maybe you just need to turn off the network for a while and say, whoa, and then you get budget. No, anyway. So this is what we do. So we build a BGP, EVPN, VXLAN everywhere. So that means that our cloud core, as you call it, runs BGP, the top of rack runs BGP, and the hosts underneath, they also run BGP. I've done many talks about this, so look it up. I did a workshop in November in Madrid, so you can look at the slides and the video on how to deploy in more configuration details. But this is what we built. So there's two pair of routers called the spine, the aggregation. They're interconnected using 100 gig, using iBGP, top of rack, all eBGP connections. And then there's just a bit of 10G going up towards the upstream, towards the internet, because often the outbound traffic towards the internet is much less. It's the inbound, the internal traffic, Ceph, hypervisors, migrations. This is where the true traffic is. I think these deployments can do hundreds of gigs internally, and then outbound a few gigs. Because we're quite boring. We're doing email and web hosting and those kinds of stuff. So the outbound traffic is not that much. It's usually internal. So. And it's a completely IPv4 and IPv6 environment. So the tenant networks in here for the CloudStack networks, they are completely dual stack. So yes, I always talk about this stuff because I think not enough people deploy this yet in their environments. Again, everything starts with the network. It's the foundation here. Nobody takes a look at it because we just assume it's there. The building is still standing. Well, you want to paint this part, right? And you want to refurbish and refurbish the building, but you don't want to do anything on the foundation because that's boring. The city where I live is near a river, and there's a lot of houses there are sinking slowly because the groundwater is actually lowering. But nobody wants to spend money on the foundation of their house. And you see a lot of buildings starting to crack and slowly shifting. It's super expensive to do something on the foundation. Because why would you do it? What's the return on investment? It's going to take years, yeah, right? But at some point your house will cripple. So the network setup, as I said, 100 gigs internally, 25 gigs downstream towards the hypervisors, full layer 3 network, so there's no VLAN present in the whole network. It's a completely layer 3 environment. BGP everywhere, up to the hypervisor. It runs the FRR routing daemon on the hypervisor. There's a mixture of Juniper and Cumulus, IPv6 first, so we deploy v6 at first and only v4 where really needed. Ceph storage runs v6, most of CloudStack runs on v6 underneath, and there's a few v4 things where we need, and BGP runs on v6. Again, I recommend you looking at one of my previous talks. So with VXLAN, it encapsulates your Ethernet packets within UDP. So in our network, you'll see a lot of UDP packets going around between the hosts, between the switches, between the routers, just forwarding UDP packets where we have the Ethernet packets encapsulated. So if you look at that packet, it has a VXLAN header, a 24-bit, a network ID, so a VNI, a VXLAN network ID. That's a tag which is being added to the UDP packet and it flows around. So this is a UDP packet. It goes somewhere. And of course, BGP makes sure that the packet is routed to its destination. BGP makes sure all the routes are exchanged. EVPN is an extension on BGP so that we can also distribute MAC addresses. Where can a certain MAC address be found? BGP makes sure that all the hosts, all the top of rack switches and the cloud core knows where each MAC address is located, so that whenever one host wants to send a packet to the other host, it looks up in the routing table and it can send the packet to the right destination. What it will do, it will create a UDP packet with VXLAN saying this packet needs to go to the other host. And then it's routed to the other hypervisor, it decapsulates the packet, and it looks in the packet, hey, this is for the virtual machine, and it hands over the packet to the virtual machine, and it does what it needs to do with the packet. So it's a very flexible setup, and if you're into networking, this provides you a completely layer 3 network with BGP and all the magic which BGP brings. So we operate in these kinds of layers. Often most cloud deployments go up to layer 2 with VLANs, but we actually go up to layer 4 because this is where the UDP packets live and flow around the network. So if you would deploy this with CloudStack with a single zone, again, upstream network, BGP, Cloud Core, talking iBGP, this is where the gateways for the virtual machines live, top of racks, and we just keep adding as much top of racks as we want until we run out of ports here. That's what we have. Let's make it multi-DC. It's that easy. You just copy it and run an additional redundant pair of cables and establish BGP sessions. That's about it. And then suddenly this DC can now exchange MAC address information using EVPN between the two data centers. It's that easy. And you both connect them to upstream and you're done. So you can now say that in this case your zone was a single data center, and now you say no, my zone is going to be a multi-data center. So my city is my zone, and I just have DCA and DCB where I have top of racks. You can of course also do this within single data centers. I know that there are larger data centers out there which are actually not a single data center. There are multiple DCs within the same building. They have different generator sets and different UPSs, different cooling. So you won't have the latency, because it says there might be latency here. Yes, if you stretch this cable too long, you'll simply have the laws of physics telling you that it will take time for the packet to arrive at the other destination. But yeah, as I said, there are multiple DCs which are modular data centers, and you can ask them, can I rent cabinets in 2 different modules of you? So you'll probably have not going those dates, they won't go down at the same time because different generators, different UPSs. Again, it's so easy to do this if you just run BGP. Now,
with this setup, from the user perspective, that is renting VMs, then they seem like connected over layer 2, right? Although they are in different DCs. Right?
Yes. So, if you, I'm going to get to it in a moment. I'll remember your question for a second.
For the broad system.
Yeah. So, and as I said, once you have this working setup with BGP and EVPN in one data center, it's fairly easy to expand it and to go into multi-DCs. But it starts with the foundation of your network. If you currently have a spanning tree environment, it's nearly impossible to stretch to multi-DC. If you have a very small deployment, even if it's a single rack, you say, I'm going to build a VXLAN environment with BGP and EVPN, you can keep expanding. It's way more flexible. So it's a mistake I see from other people say, I'm too small to deploy BGP and VXLAN, it's too difficult, I have a small deploy, but no, think big, think ahead. And you don't want to do such a network change afterwards, because that will be horrible. So if you're looking into a greenfield deployment, I truly recommend you looking into it. And I would also like more users to use it, but currently I see if anybody has a question about BGP and EVPN, they email me. Or in the mailing list, they CC me in the mailing list. I would like to have more people answering questions on the mailing list on getting these kinds of things deployed. So, yeah. So that's about the thing. But there's a bit of magic here, which are called the VXLAN Anycast gateways. So if I have a deployment in a single data center, the core here has an autonomous system assigned. I assume everybody knows a bit about BGP, where you have autonomous systems numbers. They have a AS, and then the top of rack has a different AS, and the hypervisors down here, they also have the different AS. We have the Anycast gateway living on these, what we call the core. There we have 2 routers being the Anycast gateway. But if I would now split this into multiple data centers, I'm taking away the top of rack. I have my core in DCB and in data center A, And my Anycast gateways are simply configured on 4 devices. If I have a virtual machine here who wants to talk to the gateway, it's BGP which says, this is the closest one. I'll route your packet to this one. And it then will forward the packet to upstream or to whatever location it needs to go, depending on what the routing table in that device says. If I would like to go for 3 data centers, a bit more lines here, but I have data center B, data center A, data center C. Data center B is actually even not connected to upstream. Only these 2 are connected to upstream, but this one has 2 paths for traffic to flow towards upstream. But I configure the gateways on all locations. If there's a virtual machine here, it will hand over the packet to the core here. It will inspect the packet, determine what it needs to do, forward it to C or to A, or maybe forward it to C and it flows out through upstream towards the internet. If a packet comes in again, upstream sends it to A or to C. They will determine where it needs to go, forward the packet to B, depending again on the topology, what the current state is. So let's take a look at a tenant network, how you would configure this in CloudStack. If I create a network, I would say a VXLAN network, a VNI 699 again. This is the VNI 24-bit. So you can create up to 16 million networks, depending on your vendor of the switches. But theoretically, you could create 16 million networks. But I must say, I think for most deployments, having a couple of thousand networks is already a large deployment. So the limitation of VLANs with 4K VLANs, not many CloudStack deployments hit the 4K VLANs. I assume maybe there are deployments which go far beyond. But let's say VXLAN provides you the flexibility. So yeah, it's added to the UDP packet and the packet goes out. So an overview, this doesn't render that great. Our tenant networks, you would see VXLAN, all the IDs here, and a V4 and a V6 subnet configured for those VNIs. So let's take VNI 699 as an example again. We allocated V4 subnet, a V6 subnet. We're going to implement this on a Juniper MX router. And I create a called IRB. I don't know the acronym anymore. Does anybody know? Yes, thank you, thank you. For family iNet, we configure the V4 address, so .1, and for V6, the .1, and we set a static MAC address. There are multiple ways you can implement Anycast gateways in VXLAN. In this case, I'm going to use the duplicate MAC address, but you can also have duplicate IP address, unique MAC address per gateway. There are multiple deployments you can think about, and it's too difficult to go through this within 30 minutes in such a presentation. For V6, we're going to send out router advertisements. I need to change it to 699. I see, I forgot this part. It needs to be 699. I'm going to set out a prefix, and then I'm going to be connecting for VNI 699, the gateway on the IRB interface so that it's now present there. So if a virtual machine would get a V4 address or a V6, it could connect to either of these gateways. And that's the information you would give into CloudStack. CloudStack has no idea about stretching over data centers. You just tell CloudStack in the form where you create a network, you say, this is the V4 gateway, and that's the range of addresses you can use. A virtual router will pop up, it will become the DHCP server, and the DHCP server will just tell, this is the gateway, and let the network handle the rest. CloudStack doesn't matter. CloudStack just needs to know the VNI number, 699, and the address is configured in that network.
Just to make it clear, you assume that this multi-center data center is a single zone in CloudStack, right?
Yes, yeah. I'm going to get to that because my idea indeed is that if you do this, VNI 699 lives in the complete network. Yes, you can create VRFs, you can do many things, but let's assume you have a single deployment of that network. Every core router, as we talked about here, has the virtual gateway configured. When a VM sends a packet to the gateway, BGP will just find the shortest route to that gateway. That depends on where the VM is, if it's its local gateway or another gateway. Virtual machine, gateway, BGP will do it. So your zone will be a city, and then you could say your pods are a data center, and then your racks are clusters within that environment. And you can just spawn VMs in multiple data centers, migrate them between data centers. Again, latency of fiber is something you need to think about, but depends on your implementation. So, zone is a city, a pod is a data center, cluster is rack. Easy, right? It's that how you could do this. But there's a bit of advice. Take it easy. On the mailing list, I see people trying to do VXLAN for the first time and doing CloudStack for the first time and getting it right at the first point. Just make sure you deploy a bit of Linux boxes and get VXLAN up and running. They can ping each other. You say, hurrah, and you go bigger. Keep CloudStack out for a moment. Just make sure you really understand how the BGP stuff works. And once you say, yes, I mastered it, I know how it works, then start deploying CloudStack. Otherwise, you have to learn two things at the same time. You don't know if it's actually a VXLAN problem or it's a CloudStack problem, or usually it's, problem exists between screen and chair, which is the human, right? Between keyboard and... but build something just for plain Linux. I would say integrate v6 into the environment from day one, and be ready to fail and get frustrated. That's it.
That's how you learn.
That's how you learn. That's how you learn. And BGP allows you to create amazing things. And what I always say is that the internet is a chaos. And it works because it's a chaos. We have cables running everywhere between networks, but suddenly when we deploy our own network, it needs to be this complete hierarchy from core, spine, core aggregation, completely symmetric. But on the internet, we don't care anymore. But a packet just goes somewhere. Connect whatever you like, how it works. BGP will just solve it for you if you configure it properly. So what I did here, some people say, no, but DCB also needs upstream. No, it doesn't. It could also be that A only has the upstream, or you connect it whatever you like it, whatever works for you. As long as you know how to configure BGP, you will be able to do so. Get your flexibility, because if you follow vendor guides, you will be sucked into a tunnel by stuff what only the vendor. Read them, but try to understand what they are technically doing. So read something from Cumulus, from Juniper, from Cisco, and saying, they're actually all doing the same, but they're presenting it in a different way. They all have their own naming schemes for all kinds of things. For, I don't know, I never follow the naming schemes for certain deployments. Somebody said, oh, you have a CLOS deployment. Like, what? I don't know. We just have a deployment which works, but we're not using anything which is written in certain ways. Use whatever you like. So use it as an inspiration instead of a guideline or tutorial. A bit of like the VMware stuff. Yeah, we have DRS. Yeah, no, you have automatic load balancing. DRS is just a feature from VMware. Marketing. So my summary is that network is the foundation of your environment. You get all the flexibility by just using these protocols, implement them the way you like. Go for L3 completely. Eliminate L2, and that allows you to use a VNI in any data center. This could be within a data center, mini data centers within one data center. Whatever works for you. But I would say that 2 data centers is probably not enough. Go for 3 if you want to start, because I think the Linbit guys will like this as well. 2 data centers is pretty difficult to do a failover. You need somebody to have a quorum and say, hey, you're down, no, you're down, no, you're down. You need a third one which says, okay, no, it's going to be you who's down. So if you go multi-DC, go for 3 data centers, and it doesn't have to be difficult. It can be one cabinet. It can be one cabinet which is sufficient. But again, as I said at the beginning, data centers don't fail that often, so make the business case. Do you want to spend the money on multi-DC, or you want to spend the money on something else? You can spend it once. Keep that in mind. And that's my high-level overview, all the technical details. That's really up to you to dive into. Maybe look at one of the previous presentations where I have some config examples. But there's no guideline which can tell you exactly this is how you need to do it. It depends. That's about it.